Yesterday or last day we looked at review of trigonometry. Today we're going to take a look at solving problems where we have a couple of different triangles. So example number 1, we want to find side x. And we know that we want to use SOHCAHTOA, so we need to have one of our ratios. If we need to solve for a side, that means we have to have an angle and a side that we know. So taking a look at triangle BCD, this triangle in here. Well, we don't have another side. We only have an angle. We don't have another side to use any of the ratios. So what we want to do is take a look at our other triangle, side ABD, and figure out if there's information there that we can use to figure out something to use in our other triangle. So we notice that side BD is the same side in both triangles. So it's common to both triangles. So if we can solve for BD in triangle ABD, then we can have our second side that we need to know in the other triangle. So that's exactly where we're going to start. And in order to do that, because we have a couple of different triangles, we want to be specific about which triangle we're working with. So in triangle ABD, we want to find side BD. So using SOHCAHTOA, we're first of all going to take a look at relative to our 56-degree angle, we have our adjacent, and we're looking for our hypotenuse, which means that we need to use cosine. So we are going to use cosine of our 56-degree angle, has to be our adjacent, which is 150.5, over side BD. Now, we want to solve for BD. When BD is on the bottom, we cannot solve for it where it is, so we have to move BD first. So we're going to take BD over to the other side and multiply it by cos 56, and that's going to be equal to 150.5. Well, now to isolate side BD, we're going to take our cos 56 over to the other side, and we're going to divide. So to figure out what side BD is, we put into our calculators 150.5 divided by cos 56 and equals. Now, because we're using this in the next example, we want to keep at least one or two extra decimal places. So we find out that side BD is equal to 269.14. So we now have side BD in our other triangle that will help give us a ratio to use there as well. So now, in triangle BCD, we're going to find side X. And to do that, we're going to use our 35-degree angle. We have now our adjacent, and we're looking for our hypotenuse. So we're going to use cos 35 is equal to our adjacent, 269.14, divided by x. Now again, x is on the bottom, so we have to take it over to the other side first. Now, what we can do is do both of these steps in one step. So we're going to take x over to the left-hand side. At the same time, we're going to take our cos 35 over to the right-hand side where it becomes dividing. And we find out, now we can notice we want to round to one decimal place. This is our final answer, so we're going to round this now to 328.6. Now, notice we did a lot of steps here, various different things. So we want to do a therefore statement. And we know now making sure we put our units in there, that x is equal to 328.6 meters. So again, it's looking for what information do we need in the triangle that we need to solve for, and how do we get that from the other triangle. Our second example for today, and again, we want to find x, or in this case, we want to find theta. So theta is our missing angle. So taking a look again, we need theta in here. In order to find theta, and sorry guys, we are solving for x over here. So we need to find theta first. And the reason that we need to find theta first is that in triangle TUV, in order to find x, we would have to have an angle. We do have a side, but we don't have an angle. Well, in order to get an angle, we notice that we could find angle T in this using the fact that these three angles have to add up to 180. Remember, any straight line from one side to the other is 180 degrees. We have 93 degrees in the middle, and if we can find theta here, then we can find 180 minus the other two to get our angle in triangle TUV. So, looking at triangle RST, we have two sides. We have our 54.8, we have our 45.2. So we can find theta using those two sides. Relative to theta, we have our opposite and we have our hypotenuse. So we're going to use sine of theta is equal to 45.2 divided by 54.8. And in order to find theta, we're going to do our inverse sine of 45.2 divided by 54.8. So when we do that, we find, and again, we're going to keep this to an extra decimal place because we want to use this in the next step. So theta is 55.57. So now we know what theta is. We know that in triangle UTV, we can now find angle T. And notice that we have to specify what triangle, because technically there's three different angle T's in this triangle all around our label of T. So in triangle UTV or TVU, or however we want to put it, angle T is equal to 180 minus 93 minus 55.57. So angle T is equal to 31.43 degrees. And this is because of our angle sum of a triangle theorem that we talked about last day. So now we have an angle in triangle UTV. Now we can use that angle, and we're going to use our opposite and our adjacent, which means we're going to use our tangent ratio. So tan of 31.43 is equal to x over 63.1, which means that x is going to be equal to 63.1 times the tan of 31.43. And that's exactly how we put it into our calculators. 63.1 times tan 31.43, which means x is equal to, now this is our final answer, so we can round this to one decimal place, and we get 38.6, because we've done a lot of steps here, we're going to do a therefore statement summing up what it is we found and that we recognize that this is our final answer of 38.6 meters. Okay, so just keeping in mind there are various ways that we can figure out what we're missing. Just don't forget everything else that we know. 3 angles add up to 180. Opposite or isosceles triangle theorem, 2 sides of our triangle are equal. That means the angles opposite are equal. And we can use those to find missing pieces from triangles that will help us figure out exactly what we need to know.